Factorials! Okay, there's a reason I'm using an exclamation mark and I'm super excited. Factorials are very practical and they basically have to do, in some sense, with how many different orders things can happen. This does not sound like a calculus topic, but trust me, we're getting there. It's going to be great. So if I had one pet, and we're just going to use basic letters, A. If I have a pet and it is an alligator, I have a pet alligator. So one pet. And I want to take my pet alligator, Albert the alligator, to the vet. I would take Albert the alligator, and as I walk into the vet, this is a dumb question, but like how many different orders can you take your one pet? One way. Like I'm going to walk in with Albert and be like, I got my alligator, and they'll be like, okay, thanks Adam, without Albert the alligator. One pet, one order. All right, so far it's awkward and weird and really hard to explain what's going on. But here's the deal. If I had two pets, I have a pet alligator. I also have a pet baboon. I could walk into the vet with my alligator and then my baboon, or I could walk in with my baboon and then my alligator. So if I have two pets, there are two orders I could do that. So there's two different ways I could do that. Well, let's have three pets. I'm going to have an alligator, a baboon, and a cow. Alligator, baboon, and a cow. Walk into the bar. Walk up to the bartender and says, we're in a calculus problem. Bartender looks at him and says, how many different orders could you walk in? The answer was, let's find out. So I could walk into the vet with my alligator first, then my baboon, and then my cow. This is a dumb example, isn't it? I could walk into the vet with my alligator, then my cow, then my baboon. Now, we're avoiding all the predator-prey issues because your alligator is probably going to eat your cow, and that's a whole different problem right there. Like if you take the baboon first and leave the alligator in the car with the cow, why is there a car that holds an alligator and a cow? Anyway, I'm going to list all the possible orders. Alligator, baboon, cow. Alligator, cow, baboon. Okay, maybe I could do the baboon first, then alligator, then cow, or maybe I could do baboon first, then cow, then alligator, okay? Or maybe I could take the cow first, and then the alligator, and then the baboon, cab, or I almost said calculator. I'll take my calculator to the vet, and then the baboon, and then the alligator, and this is all I could do. So there are 6 orders, okay? Well, let's suppose I have 4 pets. Oh boy. It gets out of control very quickly. So one pet, that's a dumb question. I'm going to take my alligator, Albert. Here he is. I have 2 pets. The baboon and the alligator, this order or this order. 3 pets. Wait a minute. Now 4 pets, things get crazy. Let's go about this a different way. I have 4 pets. An alligator, a baboon, a cow, and let's not say dog, that's too ordinary. A dromedary camel. I have 4 pets. They're in the car. I'm out in the parking lot at the vet thinking, okay, who goes first? I look and I say, well, I have 4 options. There are 4 different animals I could choose from. And I pick one. Doesn't matter who. I pick the camel, the dromedary camel. I forget if they have 2 humps or 1 hump, or I forgot. Anyway, it doesn't matter. So I picked one animal out of 4. These are my options. I'm listing my options. Okay, so I take the camel in, I come back out, and nobody's eating anybody miraculously. We're all okay. They all fit in a car. It's weird. And then I say, okay, who's next? And I look, and I have 3 options. And then I pick somebody. It doesn't matter. Baboon. Camel's inside, going to the vet with a baboon. This is like a really bad joke. And so I go back out to the car. Who's left? Alligator and cow. 2 options. You can see where this is going, right? So 2 options, and I pick somebody, take the cow. Alligator has to sit there. He's messing with the like automatic window things, rolling it down, rolling it up. I'm like, hey Albert, stop that, you'll break it. So I take the cow in. Come on, Bessie. Goes in, ringing the little bell, and then all that. And then they're like, oh, well, it just needs to be milked. Well, not he, but she needs to be milked. So come back out. All right, who's left? 1 animal is left. and I multiply my options together. I could have done that on this one, or this one. It was just much more fun to talk about random animals that fit in cars that really don't fit in cars. And so 4 times 3 times 2, I was thinking ahead, what's the next one? What comes after 4? 4 times 3 times 2 times 1, that's 24. So I could list them and we'd be here a while. So there are 24 orders. This is not a subtraction sign. I probably should put a colon or, no, I don't put equals just because. Okay, next question. You have, this is not the next question, you have 5 pets. Okay, if I had 5 pets, this is not on paper, we'd do this, and then I would have already had multiplied by 5, 24 times 5 is 120. Okay, shortcut time. Factorials are shown with, you guessed it, an exclamation mark, and they look like this. So 1 pet would be 1 factorial, which is 1. 2 pets, 2 factorial, which is 2 times 1, which is 2. 3 would be 3 factorial, exclamation mark. You'd be like 3 if you want to be all enthusiastic about it, and be 3 times 2 times 1, which would be 6. 4 factorial would be 4 times 3 times 2 times 1. We did it on the board a second ago. 4 times 3 times 2 times 1 equals 24. And so the next question says you have n pets, and then how many different orders can you take them in? If I have n pets, then I'm going to have n factorial orders. And if you really want to get technical about it, because I think it's good for us to kind of have an understanding of this, is n factorial is really n times n minus 1 times n minus 2 times, okay, and you know where this is going, n minus 3, n minus 4. How big is n? I don't know. Do you want to list them all day? No, me neither. So dot, 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 3, 2, 1. Now, also, if you're looking at this saying, why would we multiply by 1 at the end? It changes nothing. I hear you, but for consistency with what factorial truly is, I like to put that multiply by 1, the times 1 at the end. So yeah, I like to do that. Let's see. We are going to write the listed factorial notation, no more pets, sorry. Write the listed factorial notation for n plus 2 factorial. So let me erase what we have. So the next question says, write it as a list. So n plus 2 factorial is what? Okay, if I started counting down, I'd say, well, let's start with what I have, and then multiply by 1 less than that, and then multiply by 1 less than that, and then multiply by 1 less than that, and then at some point you get really tired of this process and you're like, hey, I got the pattern. So multiplied by, let's keep going, 3, 2, 1, done. There we go. Okay, we've done all that, so we can build some understanding. The next 2 problems are going to help us gain an understanding of how to simplify factorials, and here they are. If I had n plus 2 factorial, and I divided it by n factorial, then I would have some amazing stuff. This is going to be great. You're going to love it. So let's list some things. Let's do the numerator first, because we should. N plus 2 factorial is n plus 2, n plus 1, n minus 1. Okay, stop. Stop right there, stop right there, stop right there. We just did this exact same thing right here on the previous problem. And n times n minus 1 times n minus 2 times all this stuff right here, that is n factorial. It's all there. Everything from n all the way to 1 multiplied together, it's all there. So don't list anymore. Stop, please. In the name of love, before you break my heart, think it over. You're welcome. N factorial is the denominator. Feel free to list it if you want to waste your time, but there you go. Do you see what I see? I do. I sure do. I see what I see. Final answer is n plus 2 times n plus 1. Multiply it out if you want to. We're all adults here, so let's just leave it. Okay, one more little part of this, and we are asked to find, to simplify 3n minus 2 factorial over 3n all factorial. Things get a little tricky on this one, so let's erase some things. 3n minus 2 factorial over 3n factorial. Okay, let's start. I'm very tempted to start with the numerator in this case, but the numerator actually is less than the denominator. It's 2 less in a sense. Not exactly 2 less. It's not going to be 2 less at all. But it is less in that we are starting counting down at a lower number. So let's start with this one. This is 3n times 3n minus 1 times 3n minus 2 times 3n minus 3 times 3n minus 4 times 3n minus 5. And we're going to go all the way down. Don't let the 3 in the front throw you off. We're still just counting down, and it will go on forever. Well, this is the numerator. So 3n minus 2 is my numerator. And all I have to do now is grab my marker and cancel. And I have 3n minus 1. And the numerator is 1, because when they cancel, they divide out, makes a 1. And that is an intro to the glory of factorials. By the way, factorials are the fastest growing graph that I can think of off the top of my head. I mean, you can modify it and make it like 3n factorial, make it even bigger, but just in the general sense. When we were talking about limits at infinity, the biggest magnitude was factorials, and this is it. So this is more powerful, so to speak, higher magnitude than anything that is exponential, anything you've studied before. So we used to look at these graphs and be like, man, that grows fast. And then we were like, oh, that grows fast. And now we're like, well, that doesn't grow fast at all. And now we're like, that grows the fastest. Weak, strong, very strong. Good to know.